Welcome back, everybody. We're in section 5.3 on sublevels and orbitals. So we know what a shell is. A shell is a concentric area or region of space where electrons will spin around the atom. And when we looked at the periodic table, we remember that, say, period 1 would have 2 electrons in it because there are only 2 electrons on the periodic table. There's hydrogen and helium. So that shell is completely full with 2 electrons. So that whole shell. Now we're going to see that as electrons, especially as they get more abundant, they go in various regions of space. And this is explained by a ridiculous math. You couldn't even write it across this page. It's a huge math equation, and it's statistical analysis of where you might expect electrons to dwell, since they're all negative and want to get away from each other, and they're traveling at the speed of light, and et cetera, et cetera. It breaks your brains. But if you want to think of it in an easy way, I'll give you an easy way to do it. I think of an orbital as a room at a college where 2 girls have to live together who hate each other. So an orbital can hold 2 electrons. And you can have regions of space that have more than 1 orbital in it. Okay, so we'll look at this later. So sublevels are regions within a shell where electrons are expected to be. And some are cheap rooms and some are more expensive rooms. So the kind of rule of thumb that I imagine is that you are going to always pick a cheap room until all the cheap rooms are gone, and then you will pick a more expensive room. Now, what I'm talking about, expensive, deals with energy. The lowest energy level, that's where an electron's going to be, because it's like, how far does water fall down? It goes till the bottom and then stops, okay? So it pools somewhere and stops. As soon as it's stable, it stops. That's what happens. An electron is going to go down to the lowest possible energy level and then stop. And if those are all occupied, it'll move up to a higher energy level. And that's the way it'll do until we run out of electrons. All right? So your energy level, I think of the periodic table. It's the rows on the periodic table. So they're assigned quantum numbers. So n equals 1 is row 1, or shell 1, or hydrogen, helium. N equals 2 is the second shell, lithium, beryllium, etc. Okay, and then it just keeps going down. You get to the seventh shell, and as we create new elements or find them, we will simply put them in higher and higher shells. Okay. A sublevel contains electrons with all the same energy. So think of a sublevel as an apartment that has a certain cost and that all of the people pay the same rate for, and there's bedrooms off of a common apartment living room. Okay, so it would be like a dorm room, but it would be like a suite that all of them are paying the same money. Okay, so you can have cheaper and more expensive, and they'll always go to the cheapest if they can. But you're going to have the same energy level in a subshell. There are 4 subshells, or 4 sublevel subshells that we would know about. Now, theoretically, there's more, but in terms of all the elements that are known, they all can fit within these 4 subshells. The lowest energy level subshell is an S. So if it's available, an electron will live there. Okay, it's the cheapest room. Then the P subshell is next. Okay, the P sublevel or P subshell is next. Above it is the D, and then last and most expensive is the F. In the first shell, there is 1 subshell. In the second shell, there's 2 subshells. In the third shell, there are 3 subshells. In the fourth shell, guess, there are 4 subshells. Now that doesn't mean there are 5 in the 5th subshell. I guess theoretically there would be 5 in the 5th shell, but every element that we know about is already completely used. So we don't need a G. I think a G is the next one they would use. But you're going to see is if there is 1, it's an S. In the second one, you need 2, and the 2 will always be an S and a P. So in the first shell, you're going to have 1 subshell, and it's an S. In the second shell, you're going to have 2 subshells, an S and a P. In the third shell, you're going to have 3 subshells, an S, a P, and a D. And in the fourth shell, you're going to have 4 subshells, S, P, D, and F. Okay. Now, I told you that an orbital was a room that 2 college girls that hate each other have to live together in. So we're going to see that one of these boxes in this picture is an orbital. All right, that means that in the S subshell, there is only 1 orbital. In the P subshell, there are 3. 1, 2, 3. So in the P subshell, there are, so an S is going to have 1 orbital. The P will have 3 orbitals. The D will have 5. 1, 2, 3, 4, 5. And the F will have 7. 1, 2, 3, 4, 5, 6, 7. Now, if you remember, an orbital is a room that holds 2 girls. So each orbital holds 2 electrons. So in this first shell, you've got 1 subshell. That 1 subshell has 1 orbital in it. And that orbital can hold 2. So in the entire first row, you can hold 2 electrons. What are they? Hydrogen is 1. Helium is the other. So the whole shell is filled with the S subshell. Okay, so what do we see of the next one? The next one is going to be, let me see if I can pull up a periodic table without too much weirdness. Okay. All right, let's see if this makes any sense to you. In the first, I'll use a light. In the first shell, I've got 2 electrons. That means it's in the first orbital here, the S orbital, and an S orbital has 2 electrons in it. So there's only 1 subshell, the S. There's 1 orbital in that subshell, and that orbital holds 2. In the second, I've got 1, 2, 3, 4, 5, 6, 7, 8. Okay. I've got 8. Now remember, I need 8 divided by 2 orbitals. So I need 4 total orbitals. Well, in the second row, I've got an S and a P. An S has 1 orbital and a P has 3. So what will happen is lithium will go in here, beryllium will go in here. Now this room is full. The next will be boron. Boron will go in here. Then carbon, nitrogen, oxygen, fluorine, neon, and they fill the rest of the Ds. So this shell is full with an S and a P. Here's where this gets a little bit weird. The sodium, magnesium, aluminum through argon looks like it's another 8. Because I don't see anything here, it looks like it's another 8. So it appears like it should be like group 2, where there's 1 S and 1 P, and you've got 1, 2, 3, 4, 5, 6, 7, 8. But what's actually true is that these guys right here are your Ds. Do you see I've got how many orbitals in the D? 1, 2, 3, 4, 5. So that's 10 girls. 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10 girls in the Ds are here. Okay? These are the Ds. And guess what? These are the Fs. They live here. Okay, these inner transition metals are the Fs. The first 2 go in here, then the rest of the 14. And so there's 7 orbitals, 14 here because there's 2 girls in each room. All right. So why is row 3 have a D, but I don't see it? It's because these guys are actually in the D. They're 1 off. So they look like they're in shell 4, but these electrons actually are in shell 3. Okay, and sorry that makes your brains hurt, but you can figure it out. You're going to see also that this group should be in group 6, but it shows me that I have an F in group 4. So these are 2 off, 1, 2. So the D subshell is actually 1 ahead, or 1 behind, and the F subshell is actually 2 behind. The F subshell is in the 4th shell, and the D subshell is in the 3rd shell. I'll try to help you understand this. So this is some review. An orbital is a space that 2 electrons reside that do not want to be together. They're both negative, and they are spinning in opposite directions. One is spinning one way, and the other is spinning another way, and they want to stay away from each other if they can. So they're like the 2 college girls that hate each other. So we depict that with showing inside the orbital. Remember, a box is the orbital, holds 2 electrons. Here's 1 electron, here's the other. One is spinning in one direction, the other is spinning in the other direction. So when we start filling these boxes with arrows, that shows you, that I've got 2 electrons, but it also shows you that I have opposite spins on those electrons. Okay. The s orbital, in terms of shape, is spherical. Okay, it can hold 2 electrons, so 1 electron would be over here, 1 would be here, and they would stay away from each other at all points. So as they're whirring, 1 would be here, 1 would be here, 1 would be here, 1 would be here, and they're always trying to stay away from each other because they're the same charge and opposite spinning. So you can depict it as a sphere. Okay, so the 1s would be smaller, the 2s is farther down, so it's going to be a next concentric circle, the next concentric circle, and those would be s orbitals. The p orbitals are going to have 3 rooms. Okay, there are 6 boxes, or there's three boxes with 2 girls each. So when you go back to the periodic table, you'll see that on the right side of the periodic table, there's 6 there in the top. Let me bring it down again to show you. Okay. All right. Oops. I've got so many. Let's get rid of that one. Okay, sorry. So over here, here's my S's. My S's are 1 and 2. Okay, so these guys are S's. These are your P's. So 1, 2, 3, 4, 5, 6. So I've got 6 electrons. That means I need 3 rooms. And P has 3 rooms. The first room is shaped like a dumbbell in this direction. The second one is in the y-axis. And the third one is in the z-axis. So I've got 1, 2, all at 90 degrees from each other. So I've got 2 girls living here, staying away from each other, 2 girls here, and 2 girls here. So the p orbitals looks like dumbbells. I told you that this is all done by an enormous hurt your brain math problem. The D's are so weird that they don't even have a shape. It looks like a donut, kind of with little ups and downs to it. It's kind of bizarre. And then the F's are even more ridiculous. So they're simply regions in space of probability that you're going to find an electron. Okay. So each sub-level consists of a specific number of orbitals. Now, we looked at this before. Your s orbital, or your s subshell, holds 1 orbital. Your p subshell holds 3. Your d subshell holds 5. I don't know if you can see a pattern here. Your f subshell holds 7. Okay? So you've got shells, which are rows in the periodic table. You've got subshells, where your S's are over on this side and your P's are over on this side. Okay? Your D's were in the middle, So this is your S, this is your P, this is your D, and your F's were down here at the bottom. That's how the periodic table is lined up according to where these electrons actually live, right? And so 1, 3, 5, 7. So you're going to see that in the first level, there's one subshell, and that subshell is an S. In the second level, there's two subshells, and those subshells are S and P. In the third row, in the third period, you have three subshells, S, P, and D. And in the fourth, you have four S, P, D, and F. And that's what's depicted here. And each S has one orbital, each P has three, each D has five, each F has 7. And so each room can hold 2 girls. That means this orbital holds 2, these orbitals hold 6, these orbitals hold 10, these orbitals hold 14. So if you add those up, you can find out how many electrons can be in each shell. So in the first shell, there's 2. In the second shell, there's 8. In the third shell, it looks like there's 8, but 10 of them are inside. Okay, so that means that that there are actually 18. And in the fourth row, you've got the D's are inside and the F's are inside. Okay, it looks like there's 18, but there's actually 32 because some of them are hidden. So here's some example questions. Indicate the number and types of orbitals in each following level. Okay, well, how many, the type of orbital, okay, in the 4s sublevel, how many orbitals are in an S? There's only one orbital in the S. How many are in the D, in the third D? It doesn't matter what row it is, the D has how many? Okay, well, the S has 1, the P has 3, the D has 5. Okay, and what about n equals 3? You've got an S, you've got a P, and you got a D, right? There's 3 subshells in the row 3. So how many orbitals in the first one? 1. How many in the second one? 3. How many in the third one? 5. So how many orbitals are in the third period? So 5 and 3 is 8, 9. There's 9 total. Okay. The number of electrons that can occupy a p orbital. Okay. A p orbital has 3 rooms. Each room holds 2 kids. Okay. So how many electrons can occupy a p orbital? Well, I think this is a trick question. It's not that the p subshell, it's the p orbital. How many electrons fit into an orbital? Only 2. It doesn't matter whether it's a p orbital or an s orbital or a d orbital. All orbitals are rooms that hold 2 kids. The p orbitals in the 2p sublevel is how many orbitals in 2p? Okay, well, how many orbitals are in the p subshell? There's 1 in the s, there are 3 in the p, 5 in the d, 7 in the f. How many d orbitals are in the 4th row? Okay, well, it doesn't matter what row it is. How many orbitals are in the d subshell? There's 1 in the s, 3 in the p, 5 in the d, and how many can fit in the f sublevel? All right. How many orbitals are in f? Okay, there's 1 in s, there's 3 in p, there's 5 in d, there's 7 in f. Okay, so there's 7 orbitals. And how many kids fit in each room? 2. So I need 14 total electrons in that level. Okay, so I hope this helps you. This is just the very first lesson of this. I'll hit this harder later, so you can go over the video more than once if that helps you, but I will see you later.